Welcome to this video demonstration of the NWeH eHealth eLab application. In this demonstration we're going to take a look at a project to understand the prevalence of high HbA1c values for diabetics. At the moment we are looking at the main project screen, which describes the different types of project content that is available, such as data, documents, data explorations, notes, snapshots of visualizations and people. To start with, we'll take a look at data. We have some data sets already loaded into this project, but to begin with we're going to load some data from the repository. In the repository we have a list of data sets that are available from the catalogue, and we also have some pre-packaged data sets which are views produced over the repository data sets. For this data set we're going to use the Salford patient information, which is a fake data set provided for us. We have a list of columns that are available in the data set, which we can select or deselect depending on whether they're required, and we also have the option to add and remove filters across individual columns. These filters are specialised depending on the type of data held in the column. It's also possible to add link to other data sets, such as the sulfur deprivation scores in this case, which shared the super output area column. Because this is an electronic health record system, we can also now start to add in the codes that we need in order to add to the data. In this case we'll start by selecting a diagnosis, and we'll start typing diabetes. This will now do a type ahead lookup for diabetes against the SNOMED concept database. We can select and add diabetes mellitus type 2. We can add that, and we can also look at what read codes have been selected. Because we're using SNOMED CT, it is possible to link to other coding schemes to do the lookup, such as OCD10, and also use that to basically refine the coding and the searchings that we're using. Next we're just going to add in the HbA1c measurements, and we'll add that, and it is possible to filter on those individual codes as well to add to set specific ranges of items. Now that we're happy with the data set, we can just add it to the basket and then check it out. So we need to give our data set a name and a description, which will just detail what data we have asked for. Now that we've added the data set to the project, we would have potentially another option in that if we needed to go through governance approval in order to get access to that data, we could basically have to be taken through that process. As we have access to the data, we can now see it now. So the first thing that we really need to do with this data is start to basically apply methods and functions to it in order to extract the information that we need in order to do our analysis. We can apply methods from the statistics workbench. There are some basic methods in here already, such as filter most recent only, normalise the data, as well as perform life expectancy calculations and such. For the filter by latest, we need to basically select the date column that we're going to use to decide which are the latest ones and which is the value that we're actually going to filter on. So we're interested in HbA1c measurements for this. Once we've run the method, we start to build up a chain of functions that we've applied, and we can continue to add functions and work with that to basically continue to work with the data. Next we can actually then save that data set out as something that we can work with. In this case we already have some existing data sets, so we'll just jump straight into one of those. And we're going to take a look at normalised HbA1c by patient. In this one, we've added a column to the dataset which basically shows us whether a patient is considered to have a high HbA1c or not. In this case, a high HbA1c is defined as 7 or greater. And if we want to, we can also add a note to add that definition in, and we can add notes or documents and files to any of the data or the content. Once that item's been added, it becomes associated with this content so that you can always see the provenance of any content that's in the application. Next, we're going to take a look at how we can just quickly view headline statistics for the data set that we're looking at by selecting the volume column. And here we see some basic statistical information such as the mean and median, standard deviation and so on. We can also visualise the information as a chart or as a map in the case where there are geocoded columns in the data. To do this, we simply select the title and additional information that we want to add to it. We can select different colour schemes and different map sizes or chart sizes. In this case, we'll use the traffic lights. We can then select a value column that we want to display. In this case, we're going to use the is high HbA1c column, and if we wanted to, we could add another one as an overlay, and then we can select whether we want to show a legend or a zoom control on the map itself. And once we see the map, we can see how that data is visualised across the different super output areas, and by hovering over it, we also then get what the sample size for that particular area is and what the ultimate value is. So in this case, we have 3 patients with a high HbA1c or 100%. If we're happy with the map, we can then take a snapshot of it, and if we wanted to, we could then continue working with the map and produce different types of presentations. The snapshot is added just like a note, so it's related to the original item, and then we can go in and see that image file that's created, and we can download the file or use it in other applications. Next, we're going to look at data explorations. A data exploration provides the user with an easy way to take any dataset they have created and generate an OLAP cube from it. For example, if we were to select the dataset that we originally created, we can see a list of the columns that are available to add into the cube as dimensions. And we can also add metadata to those columns. This helps us to group the information more easily on the dimensions. In this case, we're going to set gender to be a gender under demographics dimension. We can add a name and then create it. Creating a cube typically takes around 5 minutes, so in this case we'll just use one that we've already created based on the same data set. Here we have a simple chart showing us the count of the patients with high HbA1c and the count of the patients who don't. And we can start to slice that data up by dragging and dropping additional dimensions onto it. So for example, we can add a ward dimension to divide those values up by ward and gender. And we can also reorder the way that those dimensions are grouped. And it's also possible to reorder and filter that information on top of that. You can also view the data as a grid so that you get a better sense of what the actual values are. And there are options to save that data out to Excel, to take snapshots and save images, as well as create a data content item based on that. Another part of the application is the people section. These are the people who have the ability to view the project and work with the project, and we can see information about them, what their biography is, and we can search across those to find people that we're interested in, as well as send them messages. Finally, we can also add data from our computer if we want to directly. Once we've created all the data and other content I'm interested in, we can also start to create a view of that data. A view is basically as a way of grouping particular content together in such a way as that we can then output that straight into a Word document. So for example, in this case, we will take our data set and the snapshot that we created and add it to our view. Once we've added those items, we can also add a note and preview that information, how it looks, and then we can export it to Word. As you'll see in the bottom right hand corner, that then downloads it as a Word document, making it easier to use that information in other sources. Thank you very much for listening to this demonstration.